So I'm going to be going over the Beehive security system, the mechanical design. So our design criteria was that it needs to be as similar to a traditional brood frame as possible, manufacturability and ease of assembly, and also the material selection. So a traditional brood frame looks like this on the left, and our new design is here on the right. Now, as you can see, the material is the same because bees are particular about material. They don't like plastics, so we chose wood. Um, we also had a similar design with the overhangs, so that way the box can sit inside a hive the same way a traditional one does. And as you can see here, this starter comb sits in on this groove, which we also have the slot for. Now here's a couple more views of our new design. And as you can see, the distance between here to this front cover was done through by testing some cameras and making sure that we had a large enough scope to see the laying pattern. Now, we also designed this for assembly to be as easy as possible, which is why the sides are the same width, the top and bottom are the same width, just different lengths for the top and bottom. And then we also use these L brackets, which are the same exact size for each one, and then the same bolts and nuts. Now, this allows for the assembly to go really quick and will make consumers very easy for them to build this box. Now, this acrylic sheet is another material selection. So the bees, again, with them being particular about plastic and other materials, we coated it in a beeswax so that way they won't be bothered by it. And another reason we chose this is because it's clear. So that way, when the bees start building and laying their eggs, the camera that sits on this back panel will still be able to see the laying pattern. Here's the exploded view of the CAD model. And as you can see, it's a very simple design, very easy to replicate and continue to manufacture. So this box was also designed, as you can see on this back side, we'll have a starter comb that covers this back panel. And the reason was so that way the bees don't put propolis on the bolt and make it tough to get the bolts out, because anytime you need to service the camera or any of the electronics, they're all going to be posted on this back panel. So you take 4 bolts out and then you can access it. So those are kind of the main design constraints that we went through while creating this Beehive security system.
Hi, my name is Hunter Culverhouse, and I am a part of the Beehive security system team. And today I am here to show you how our electrical and software approach and some of our testing. So first here is our prototype, in which you can see that we have just the LEDs mounted with electrical tape and things are connected to a breadboard. We have Velcro on the back just so our camera can be repositioned as needed and see where it is best to be permanently mounted. And then, of course, the Raspberry Pi that is powering everything will be placed inside the box along with a temperature and humidity sensor. And so, as I was stating before, the um, system will be illuminated through a LED system that works very similar to a flash system. And then this entire system will be powered through a solar panel and a battery. And yeah, so the software approach, as you can see, we have a website that is being hosted in which you can view a live stream with live red detection, temperature, and then humidity monitoring, along with graphs that display the data throughout the day. And then our camera over here, you can see will be put inside of a casing that will allow it to be protected and prevent bees from being able to get to it. And so here's some of the testing results. In this shot, we have a acrylic piece of acrylic sheet with a thin coating of wax put over top, as wax will assist the bees in building their brood off of that. And then they also just prefer whenever there is some wax to build it off of when compared to not having wax. And so as you can see that the red dots are being detected. However, there is a little bit of reflection due to the LEDs. However, these in our final design will be mitigated through the use of reflected light rather than just direct light shining onto the screen. And then up here, you can see it gives you the temperature, humidity, how many red dots it was able to detect, and then the date and time of exactly when the picture was taken. And so here's just a close-up of what the red detection in the live stream looks like. And then a close-up of the temperature and humidity charts. So these are taken, the data points are taken every 10 seconds, but if there is a sudden increase in either temperature or humidity, more data points are taken to be able to give a more fleshed out uh, graph. And yeah, we'd like to thank first off Richard Chin from Barn Owl Technologies for sponsoring this project. He's the person who pitched it to RIT, and RIT decided to make it the MSD project. And then along with that, our guide, Dr. Louie, and Emily Bradford from Tinker Nature Park, and Mark Almeter from Weeby Honey. They gave us very valuable insight into the hobbyist and commercial side of beekeeping and would not be able to have this design if it were not for them.